All right, so hey, we're looking at a Riemann sum partition here. The graph is f of x, oops, which I've got graphed here. And they're wanting you to partition this into 5 partitions. They give you 1, 2, 3, 4, 5. And they're, strangely enough, not even in size. This goes from 0 to a quarter, so that's from here to here. The next one is from a quarter to a half, which is from here to here. And then we've got from a half to 3/4, and then 3/4 to 1. And then this last partition is from 1 to 2. So it's really large, this large partition. Here, they're giving us the x value within each partition that they would like to use as a reference point to evaluate the function. Okay, so when they tell us u1 here, they're kind of saying take 1/8 and use that as the x value to get the y value for this partition. Okay, so here I'll show you on the graph here. So basically, here's the whole thing, by the way, and then I'll go back to the graph. You basically evaluate the function at each of these u's. So this is u1, u2, u3, all the way to u5. These little are delta x1. That should be a 1. I wrote an I, but it should be a 1. The delta x1 is sort of the difference between these two things. So notice what I'm writing here. This is f of u1. So it's just the function evaluated at u1. This is a simple function. It's just x. So I would just put here 1/8. If this were like, for example, x squared, then all of these things would be squared, squared, squared here. This would be squared, and this would be squared. But if it were like, the square root of x, then all of these would be the square roots. You're just kind of evaluating the function here, 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 and here. Then this delta xi is sort of the width of this interval. So notice I just took the difference between these two. And here's the width of that interval, and that one, and that one, and that one. And basically what they're having you do there is make each one of these, notice, would be a rectangle, okay? And this rectangle is 1/8, or it's this, you know, uh, you know, height and its width, and you're basically taking all of these rectangles and you're summing them up in order to get a value of the area under this curve. Though obviously this is not a very good estimation because this last partition is badly done. Okay, but the reason why they're doing this, they're having you do this, is for you to kind of start to understand this notation as well. I didn't actually solve this one, but basically what you would do is you would solve all of this stuff right here, and you would end up getting, I don't know, actually I didn't do it, but you get some kind of number there. I just kind of wanted to focus on the geometry of this whole thing, though. Okay. And so there it is. There's supposed to be a 5 right there. I think you can't see it. It's white underneath the graph there, but this is delta x5 right there. And yeah, so notice this last partition. It's from 0. It's from 1 to 2, so that would be this, and it tells you to evaluate it at 9/8. So I go to 9/8 right here, go up, and that's the size of my partition. So that would be written here. It's 9/8 evaluated over the interval, or it's evaluated at 9/8, and it's extended over the interval from 1 to 2. So that this 1 is right here, and this 2 is right there, and the 9/8 represents, I'm plugging 9/8 into the function and going up to the y coordinate here. And as it happens to be, that this happens to be also 9/8, because remember, my function in this case is a very simple function. It's y equals x. Okay.